Welcome to Understanding Relationships Between Variables in Math. Today, we'll explore the relationships between variables in different types of equations: linear, quadratic, and exponential. These concepts are key to analyzing data and understanding patterns in mathematics and real-world applications. Let's start with linear relationships. A linear equation looks like y equals mx plus b, where m is the slope and b is the y-intercept. Graphing this equation will create a straight line. The slope represents how y changes with x. Next, we have quadratic relationships. Quadratic equations have the form y equals ax squared plus bx plus c. Graphing these equations gives a parabola shaped like a U or an upside-down U. The value determines the direction and width of the parabola. Lastly, let's explore exponential relationships. An exponential equation like y equals a times b to the x power describes growth or decay. If b is greater than 1, you'll see growth, while if it's between 0 and 1, you'll see decay. This relationship forms a J-shaped curve. Now, let's see these relationships in action through a problem-solving exercise. We'll identify the type of relationship and sketch a graph. Imagine a savings account with an initial amount x. Interest is compounded annually, doubling the amount each year. This describes an exponential relationship. Recognizing it's exponential, we can use y equals x times 2 to the t power to represent it, corroborating the doubling rate. Let's plot this for t, the number of years. We graph the growth of the savings much like an exponential J-shaped curve, representing the exponential relationship over time. Now, let's summarize today's lesson. We've explored linear, quadratic, and exponential relationships, graphing each and applying them to a real-world problem. These concepts are central to understanding patterns in algebra and data analysis. Keep practicing to master these relationships